Let's start chapter 9. Now remember, in chapter 8 we did a confidence interval, and that was where we were just trying to basically make a guess, an estimate for the population. So we were doing a proportion or an average or a mean for that population. Remember, a proportion comes from categorical data, meaning it's either yes or no situation, and a mean is where we can count something and take the average for that population. And we would take a sample, right? And from that sample, we would come up with our estimate for the population. Well, in significance tests over here in chapter 9, we're actually going to test that data and see, well, how good is that data in supporting that claim that we're going to have about the population. So anyway, I'm going to set this up in the next slide and try to do an example that gets you set up for section 9.1. Okay, here we go. Let's just say that Starbucks is getting a little nervous about Dutch Bros, but they make a claim. They say that of this demographic of students that come to their first early morning class with a coffee, only 10% are carrying a Dutch Bros. Okay, so demographic, that's kind of like our population. Students between 15 and 25 that bring coffee to class. Okay, now, let's set this up. This is called the null hypothesis, which is, this is their claim. They say it's 10%. We're going to try to prove that it's higher than 10%, which is called the alternative hypothesis. So there you go. You've got the null hypothesis right here. They say it's 10%. It's kind of like a court case. We're going to try to prove that it's actually higher than 10%. Okay, let's see kind of an example of how that might be done. Okay, so let's consider this. So stay with me on this. We've got sample size is 50. So each one of these dots represents 50 students. Okay, now this is a computer generated dot plot. If the 10% was true, this is what it might look like. Okay, so we go out and we actually get a sample of 50 students, a simple random sample, who are drinking coffee at an 8 o'clock class, and it turns out that in our sample, 9 out of the 50 have a Dutch Bros, which is 18%. Now that 18% for our sample, right? Let's compare that to this graph. Would put us, let's just say it puts us right there. That's 18%. Okay, now let's take a look at this. Well, you could say we just got unlucky, right? We just happened to get a simple random sample where a lot of students were drinking Dutch Bros. But let's take a look at the evidence here. Now, if that was true, we would only have, let's see, 5 of the samples are 18% or higher. And let's just say there's 150 right here. There's 150 in this graph right here. Well, 5 out of 150 is 0.033. Okay? So what we say is there's really only a 3% chance, approximately, a 3% chance that we would get this sample purely by chance. Okay? Now this is called our p-value. Now, if our p-value is small, like 3%, we would reject the null hypothesis in favor of the alternative hypothesis. So in this case, 3%, that's pretty small. And then we'll talk a bit later about, like, well, what is small enough, right? And we would say, okay, I do not think that this claim is true based on our evidence. Okay, so it's like a court case. All right, I know that's a lot, but if you read the basketball example in section 9.1, maybe this will make a little bit more sense. And we'll talk about it next time I see you. Okay, don't forget, like and subscribe. Bye.